Okay, in this particular lesson, we are going to go through this particular worksheet, okay? 5.5 application of graph in real world context. This is EMATS. Now, I know that I've already gone through this first page in class, but probably it was done in a rush and never mind, we will just review it lah. But if you think that you really know all this already, you can just fast forward. I don't recommend you fast forward. Okay, we will be going through these 1, 2, 3, 4 pages, and that's all for today, okay, in this video. Now, let's start with the first concept here. Okay, now, we have learned different types of graphs. Distance time graph, speed time graph, acceleration time graph. Now for this particular topic, there are only these 1, 2, 3 kinds. And from distance time graph, you can actually draw your speed time. From speed time, you can actually draw your distance time graph. And vice versa. That means going the other way around is also true. Okay, now let's start with the first one. Distance time graph, as the name suggests, is a graph of distance, okay, plotted against time, meaning the y-axis is distance, the x-axis is time. Now take note of the units here. It can be meter per second, kilometer per hour. Now here can be meter per second or kilometer per hour, or even meters per minute. So you see accordingly, and sometimes you may need to do conversion when you do your working. Okay, now the gradient you know is rise over run, right? Meaning this vertical over the horizontal, rise over run. So the rise, as you can see, is distance. The run is time. So distance divided by time, you learn from primary school, it is speed, correct? So the gradient of a distance time graph is the speed of the object. Yeah, so that's the first thing you need to know. Okay, then the other thing is this. If you were to look at this distance time graph, as time passes by, you always think of it this way, okay? As time passes by, what happens to the distance? As time passes by, right, the distance increases. Okay, at a constant rate. That means the gradient here is constant, right? That means the speed will be constant. So this means constant speed. Okay, and then you see the next part, this horizontal straight line, right? As time increases, is the distance increasing? Not increasing, right? Hey, give me a minute. Give me a minute. I forgot to turn off my Wi-Fi. Wait. Okay, can already. Because otherwise, when there's a message coming in, the whole video will be gone. Okay. Now, as time passes by, I was saying just now, as time passes by, what happens to the distance? Oh, the distance, no change. No change. That means it's not moving at all. Okay. And same here, as time passes by, the distance increases at a constant rate. So this is constant speed. These are all the basics that you need to know. Okay, now we go to the next kind of graph, and that is the speed time graph. Now, we are always interested in the gradient of this graph and this graph. Now, the gradient of a speed time graph will be speed divided by time. Now, speed divided by time, right? We call it acceleration. Acceleration means getting faster and faster. So this pen now moving across here is not accelerating, it's like moving at a constant speed. As time passes by, it moves that same distance away from the previous point, right? So this is constant speed. What is acceleration? Acceleration means like that. At first like that, right? Then getting faster and faster and faster, okay? At first slowly, then getting faster and faster. So that's called acceleration. Faster and faster and faster. So that's acceleration. Okay? Deceleration means it's actually fast, then it slow down like that. Okay? So this is acceleration. This is deceleration, getting slower and slower. Okay? Now, the area under the graph is actually speed times time. So area under graph of a speed time graph is the distance traveled. Okay, now the next thing you need to know is this one, acceleration time graph. If the acceleration is constant, for example here, always read the graph like that. Okay, as time passes by, what happens to the speed? It is increasing at a constant rate. So that means the gradient of this is constant, right? So it's constant gradient, that means constant acceleration. Okay, this one as time passes by, is it moving? Yes, it's always moving because it has a certain speed. All right, it is moving at a constant speed. All right, then this one, how about this one, the last part? As time passes by, the speed is decreasing. So this is deceleration. Okay, constant deceleration. It means the speed is getting slower and slower and slower and slower until it comes to a stop. All right, so that is what you need to know. You look here. How is this graph linked to this graph? This is the so-called x-axis. So 0 is here. Now you notice or not? If I were to find the gradient of this line, rise over run, right? Rise over run. I'll get a positive value, right? So for example, it's 5 5 meter per second square. Okay, this is a positive gradient, so it's a positive acceleration, because acceleration, right, is the gradient of the speed time graph. Okay, now how about this? Constant speed. Is the object accelerating? See, constant speed. As time passes by, I travel the same distance away from my previous point. Correct? This is called constant speed. Okay. As time passes by, right, I'm not accelerating. I'm traveling at a constant speed. So constant speed, is there acceleration? Don't have. That's why the answer is here. Okay. Now you notice we don't draw any solid line here. In fact, you don't need to dot 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 also. This dot 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 is just to tell you that this point and this point, they so-called on top of each other, overlap, so-called overlap. Then you look at the last part. I'm decelerating. Decelerating means my acceleration is negative, right? Negative acceleration, because this gradient is negative. So let's say it's 5 this will be minus 5 meter per second. All right. So this is the concepts you need to know. And the very last one is that average speed is total distance divided by total time. And please take note, here, this total time, right, includes resting time. Includes your resting time. That's why we call it average speed. All right, now let's do this first page, which is on water depth. So water depth, there will surely be a question like this in your examination. How do we do this kind of questions? It's actually pretty simple. You just need to know this concept. What concept? Let me see. Where do I put the thing? Here. This concept. Distance time graph, or that time, or two quantities. Okay, so in this case, it's that time. That means you can call it the height of the water. Okay, instead of depth of the water, you can call it the height of the water. Now if you draw a straight line like that, then it's constant speed. That means if you're talking about this part, right, I pour water in, the water will slowly rise up, right? Because the wall of the container is straight. So the amount of water to fill in for each section, they are the same. So it will be a constant speed like that. Okay, now as you move on from here, sorry, I forgot to tell you, can you change your diagram, right? Okay, what I meant in class that day, right? Liquid paper, blanco this away, start from here, then draw dotted lines at the maximum height, the minimum height, and the place, this point here where it changes from a small width to a bigger width. All this, right, will guide you. Same here. Okay, same here. This is the maximum. This is where it changes from big volume to small volume. And this is the starting point. Okay, so can you do that? Okay, now. Very simple. We were saying just now, right? Because the wall of the container is vertical. Vertical means like that. Vertical means like that. Straight. It's not like that. It's not like that. It's straight like that, right? The wall is straight. So it will be constant speed. Okay. Now from here onwards, the water fill until here, right? Then it gets wider. That means it will take a longer time. As time passes by, it will take a longer time before it fills up all this big gap, right? Okay, so you get slower and slower and slower. So this is the red one. Meaning to say, your graph will look like that. Okay, see how I draw it. At first, constant speed, right? Constant speed, then you get slower and slower and slower. So you roughly see, you plan first, you draw a straight line, then you go and cut here, right? Sorry, not cut here, you go and draw a straight line, then you go and curve down. So you use your ruler. Where's your ruler? Your ruler is here. Like that, right? You draw this. Okay. Hey, you must use a ruler. You cannot use freehand. Here to here, you use a ruler, and then at this point, right, it's going to get slower and slower. You need more time to fill up all these big gaps, right? So you're also going to get slower and slower and slower, like that. Okay, that's all. So this is a curve. Slower and slower and slower, like that. Okay, now we're going to do this and this together. You know why I put them side by side? Because this answer, right, where water is flowing out. That means now at first filled with water, then you go and drain it out, or maybe put a hole here and then you drain the water out. How will it look like? It will look like just the mirror image of this. Okay, meaning to say it's going to be like this. Go down. Okay, and then you need a ruler to draw this straight line. Like that. Can you see that it's like a mirror? So in the exam, I can tell you most of us have no problem drawing this when the water is being poured in, but you will have problem drawing this when the water is being drawn out. So what do? You if let's say this is an exam question, then they give you this blank space, right? You do this by the side, then you will know that, it's a mirror image. Then you just reflect like that, those who learn physics, it's like reflection, you learn in lower sec, you also know this. Okay, now let's do the next one. We'll go a bit faster from here. Again, please blanco this and then start from here so that you can understand better. Now, is it going to be faster and faster, slower and slower, or what? Okay, so you think about it. It's only, I tell you, it's only go straight, go down, go up. There are only 3 different cases. So which case is this? Getting faster and faster, or slower and slower, or constant? Now, constant, very simple. Constant only happens when the walls of your container are straight, vertically straight like that. Now you see, it's like that. That means as time passes by, at first you take a long time to fill, then because the gaps are smaller, then very fast you go up already, right? So it's going to get faster and faster and faster, the green one. So that's all. You draw this faster and faster and faster. You like that, finish already. Okay. If this is like that going in, then going out, right, moving out, right, is going to be the. Hey, don't start here. Don't start here. The depth is going. As time passes by, time starts from here. So you start from here. Okay, it's going to go the other way, like a mirror image. Okay. Okay. So that's all. Mirror image. So you just learn this. If they say water go in, This one no problem, I think you can do. But then when they say water come out, right, a little bit harder to visualize. So what do? You do this by the side, then you do it like reflection. Make sure this is your starting point. You see, I end here, I will start here. And of course, I must start where t equals 0, right? So that's all. Okay, now let's do the last one. Wow, this one seems difficult. At first like that. A lot to fill in. It will take more time to fill in this than this one, right? But you see, that's one thing. The other thing is, can you see this is vertical, this is vertical. So this should be a straight line. This part here also should be a straight line. Okay, but this straight line, it will take longer time than this one. That means what? That means this part here, the gradient, because the gradient is how fast the thing is. The gradient will be less steep. What do I mean? The gradient will be like that. Like that, right? This speed, right? The speed here will be slower than the speed here. Oh, faster speed means my gradient is steeper, right? Like that. That's all. Because this part here is slower, this part here is faster. Like that lah. Okay. Alright. Okay, then let's say the question asks you to do this, filling in the water. This will be how you do it. If they ask you water being drained out, then what do you do? Very simple. You go and reflect this. So this is the end. So this will be the start. Then you draw using ruler. Like that. Okay. This part is like this part. Then you like reflection like that. Okay. You know what I mean? Reflect like mirror, like the mirror image. Okay. Okay, so we have more or less covered this on what you call that? The water depth versus the time kind of graph. Now we're going to the next one. There's still one more. There's still one more. Okay, never mind. One more, the answer to do one more, then we do one more. It's okay one. No problem. We noticed that it is a vertical wall. Vertical wall means it will be a straight line here. Then this second part here, curve. It will be a curve. This vertical wall will be a straight line. So it will be a straight line, a curve, a line. Okay, for the last part. But I want to ask you, this line, okay, this line here and this line here, which one is faster? Faster, of course, is this one, right? Less space to fill. Faster means the gradient will be more. That means the gradient will be steeper. So if this is the gradient, okay, I draw first. Talk so much, no use, right? Okay, so I will do like that. So let's say this is the speed here. What I'm trying to say is this speed will be faster, right? The gradient for this part here is the red one. For the smaller part here is faster, right? Faster means it will be the blue color steeper line, steeper gradient. Understand? But in between here, may I ask you, is it going to be faster, slower, or constant speed? Red, blue, or green? Yeah, so of course this is a video, you can't answer me. You answer me also, I cannot hear you, right? Yeah, but I think many of you would know the answer. It's going to get slower and slower and slower. So you draw like that. Must be a curve. This part must be a curve. Slower and slower and slower. Okay. Then after that, right? After that, you'll be faster and faster and faster. So you need to use a ruler. Okay. Need to use a ruler. In the exam, if you don't use a ruler here, we will not give you the marks like that. Yeah. Okay. A bit not so well drawn, but yeah, but it's something like that. Okay, that means that's worse. Okay, wait. Okay, so it will be quite a marked difference from this. This gradient must be steeper than this gradient, okay? Now, how do I draw the other part? The other part, okay, must use a ruler, must use a ruler, okay? Use a ruler. And then this part here, right, will be like that. Curve, curve. Okay? And the last part, right, will be a... That's my ruler. Will be a mirror image, mirror image. Okay, down here not very well drawn. It should be a curve here, then a straight line here, okay? Straight line, curve, straight line, okay? So that's roughly how you can draw it. Now, this part really is not well drawn because the transition here, it should be more or less smooth, but mine not smooth. Next time I will pass you a better one, okay? Now let's move on to the next part. Now the next part, right, is what we call a step function graph. Is that what graph? Step function, step, like 1 step, 2 step, climb up the steps like that. Step function graph. Okay. Not very important. Not very important. You look at the O-level past year questions, right? Don't really have this kind of question. But just in case they decide to set in 2022, then we just learn why because it's very simple graph, so nothing much to set. Find the cost of postage to mail a letter with a mass of 50 grams to Malaysia. 50 grams. So you don't look here, you don't see 50. You don't do. This refers to the money. Okay, so you look at the mass, 50. Then you look here. Okay, then you go here. Now is it 51? It's not. You must be able to read graph. There are 10 boxes here, and it represents 50, right? So one box will be 5 lor. Okay, and this is one box after 50, right? So it's 55. $55. $55 to post this mass to Malaysia. Okay, now find the cost to mail a package with 125 grams to Malaysia. Okay lor, then you see where's 125. Again, look here, this is mass, so you want mass, right? So you look at the mass scale. 100 is here, 150 is here, so this must be 125. Okay, then you shoot this one. Okay, shoot this line. Then you go across. Okay, it's 180 lah. You see carefully, each box is 5. So 5, 10, 15, you go and count, it's 30. Okay, 30 plus 150 is 180. So you go and check. That's all step function diagram. So not popular in the O levels. We just do lah. So you cannot say Nanchao never teach you this. We did teach you this, right? Okay, so if it comes out right, you cannot say you don't know lah. All right. Okay, number 3, last question already. Last question already. Okay, every video that I send you will be roughly close to 45 minutes. Okay, the length of a Korean drama, roughly that duration. So you shouldn't be falling asleep. So you read this. This is the speed time graph for the first 20 seconds. Alright, calculate the speed when t equals to 4. Then you see, how? There's no t equals to 4, there's only 6 t, right? There's only 6, 14, 20. So how t equals to 4 don't have? So never mind. This question, you need to use this concept of gradient. That's one way, okay? Another way is to use similar triangles. Similar triangles. Never mind. We'll do one way first, okay? Just for today, you do one way. Now, how do you do it? What you do is this, you see carefully, okay? I want to find the speed where t equals to 4. Let's say t equals to 4 is here. You shoot up. Shoot up, right? Okay? Then this is the value that you want, right? Okay, but of course, you see, this is not what you call that? This is not a graph paper that you can read. This one is don't know what. You cannot write. There's no number here, no scale here. So you also cannot estimate. They never ask you to estimate. They say calculate. Okay. So what must you do? You must know that this is 4 and this is S. S, not 5, this S. I use S to represent the speed here. Okay, now, and you also know that this is what? If I ask you for the coordinate of this point, it is 622, right? Correct or not? Correct, huh? Okay, now do you agree? Do you agree that the gradient of this blue line, which is this long one, this, okay, let me see, I can't see the screen. Okay, this blue line, right? That means this whole line, don't you agree the gradient of this blue line is equals to the gradient of this shorter blue line? That means from 40 to here. This gradient, same as this gradient. Meaning to say, this gradient, this line, right? Oh, long line, then I have another line that overlap this. Don't you agree this red line, long one, and this blue line, the shorter one, their gradients are the same? Okay, if yes, then we can use this concept to help us to find the answer. Okay, help us to find the answer. You think of this as a right angle triangle. Think of this as a right angle triangle. Don't you agree that the gradient of this right angle triangle is equals to the gradient of this line? Okay, not the gradient of the right angle triangle. It's gradient of this line equals to the gradient of this line. Yeah, if you agree, right, then we can do this gradient of this. I write the shorter line first, okay? Shorter line first, meaning let me write here, what is this coordinate? 0, 40, right? So y minus this y over x minus this x, then that's your gradient, right? So 40 minus s over 0 minus 4. This gradient must be equals to the long line, the gradient. So 40 minus 22 over 0 minus 6. Okay. Then you what is this? You press your calculator, okay? You press your calculator. Okay. Then this will be 40 minus s equals to minus 3. So it's 12, right? Okay. Then your s will be equals to 28. Then you ask yourself, make sense or not? Make sense or not? 28, can s be 28 or not? Yes, because it's above 22, less than 40, can. Check if I make any mistake. If I make some mistake, you let me know, okay? So this is found already. Meaning to say, the speed is 28 meter per second, finish. Okay? Now, let's look at the second part. How long did the particle travel at constant speed? Constant speed means the speed didn't change. It is constant at a certain value. So as time passes by, see, it's always like that. As time passes by, did the speed change? Yeah, the speed decrease, or keep on changing, right? But now here, from 6 to 14, the speed, as time passes by, the speed remains constant at 22. So you just say, how long means how long, like how many seconds? So it's 14 minus 6, and that will give us 8 seconds, finish. Okay, easy, Okay, now the next one. Find the value of v if, where is v? V is here, okay? V is here. So they want you to find that value. Find the value of v if the acceleration of the particle in the last 6 seconds, meaning here, last 6 seconds, right? 14 to 20 is last 6 seconds, is 4 meter per second square. Now, we learn that the acceleration of a speed time graph is equals to the gradient, correct? Yeah, so this gradient, they're trying to tell you this gradient is 4, and it's positive gradient, right? So it's correct. Okay, the key, right, is always to label the coordinates first, like that. I see label like that already. Then now here you label like that. 14 and 22, right? 14 is the x value, 22 is the y value, 20 is the x value, v is the y value. Okay, now I know that the gradient is equals to 4, but it's also equals to, if I have to calculate, it will be v minus this, right? Over the x minus x value, right? Check if I make any careless mistake. So you work this out, right? You will get you will get 46. Okay, so you will get 46 meter per second because it's velocity or speed speed. Okay, so that's all for this part here. Lastly, I told you, right, exam they always they like to ask you this, confirm they will either ask you to sketch the distance time graph. Before that, they give you speed time, or they will give you distance time graph, then they ask you to sketch the velocity time graph. Very likely, class, very likely they will give you speed time graph, ask you to do this, confirm one in the exam. O level they like to do that. Okay, so sketch the distance time graph. Distance time graph means I need to know the distance after each of after each of this. I need to know the distance traveled, right? So what we learn in class, if you remember, is this. Okay, now I've enlarged this diagram here, this speed time graph into this. All right, so this is your speed time graph. From a speed time graph, ladies and gentlemen, by finding the area under the graph of a speed time graph, we are able to find the distance traveled. Okay, so the distance under this graph is the distance traveled from 0 to 6. So remember or not, I told you do by section. Remember, do by section meaning do this, okay, then do this part, then you add, then you do the final part. Okay, so that's what I'm going to do. But before that, revision time. How to find the area of a trapezium. Trapezium has a pair of parallel sides. All right, so very simple. It's something like half times base times height. Okay, it's something like half times base times height. Okay, area of trapezium is something like half times base times height. I repeated 3 times already. But the half, the half is just half lah. The half is just half. The height is just a perpendicular height. It's the same. Same. The base, the base, right? There are 2 bases because I told you already. A trapezium can be split into 2 triangles. So you see, it has one base, one height. Then it has another base and another height. Correct? So you must add the 2 bases together. Yeah, so that's all. Okay, so next time you see a trapezium, what you do is something like half times base times height. But because there are 2 bases, you add the 2 bases together. That's all. Alright, so let's see here. We can see one trapezium here. And this trapezium, let me use red. This trapezium, the height is 40. This trapezium, the height, take note, is 22. So you have the 2 bases ready, right? Meaning to say, is half times base times the height. The height is this perpendicular height, 6. So it's 40 plus 22. All right. Then you go and press your calculator. All right. Take out your calculator. Half times the base is what? Okay, number 40 plus 22. Check that I've done it correctly. Okay, then times the 6. Yeah, that's all. So it's 186. Meaning to say, ladies and gentlemen, in 6 seconds it has traveled 168 meters. That's all. Alright, now the second part is easy. It's just a rectangle, but you must be careful. It's not 14 times 22. It's not. It is this, which is 8 times 22. So you take 8 times 22, that will give us 176. Okay, and finally, it is another trapezium. Okay, just now we have calculated this to be 46 already. And this is not 20. It's 6. We want this length. Okay, so you take half times these two add together times this 6. Okay, so half times 6 times 22 plus 46, huh? 22 plus 46. Then you get 204. 204. Okay, very good. So now you see, we have the distance traveled in the first 6 seconds, the distance traveled for the next part of the journey. Okay, not this 176 doesn't include here. 176 is only here, okay? And from 14 to 20, this 6 seconds it travels this. Like that, okay? Now we are ready. Okay? We are ready to transfer this speed time diagram into the details, right, into this distance time graph. Now, firstly, you see what is going on here. The speed is decreasing, right? So don't you agree it's getting slower and slower and slower? The speed is getting slower and slower and slower, right? That means the distance is getting slower and slower and slower and slower, correct? But then here it's traveling at constant speed. Constant speed is a straight line. What? Remember we learned that just now. Constant speed is a straight line for distance time graph. This is distance time graph, right? This is distance time graph. Distance time graph. Okay, so it must be a straight line. And please, you see the transition from here to here must be a smooth transition. Okay, smooth transition, meaning it's like you sit here, then you slide down this slide. There's no bump here. That's why just now I said, right, that diagram is very badly drawn and there's a bump. Okay, now this is the right way to do it. Then you do this. Okay, a bit missed here. This is important. Okay, this is important. Okay, I get the shape first, Ken. The shape, I get the shape first. The shape will give you marks in the exam, okay? So you see, oh, now I'm getting faster and faster. My speed, as time passes by, my speed is increasing. So it's going to be like that, getting faster and faster and faster, correct? So this is the true essence of this whole subtopic. All right, you know this, you can conquer the whole world. Now, last thing is to fill in these blanks. What blanks? What distance did he travel? What's the total distance he traveled in this? How come missing? Oh, it should be 14 here. Please, sorry, 14 here, right? And 20. Please fill in. So in the first 6 seconds, what's the distance traveled? You write 186. Finish already. Okay, everybody. Now, after 14 seconds, what's the total distance traveled? The total distance traveled is not 176. It's 176 plus 186. Okay, so it's 176 plus 186. 362. So you write here 362. Okay, and finally, you have to add to 204. So just now I erased already. 204 plus 362. So it should be 566. Okay, all right. I hope that this lesson gives you a clearer picture. Okay. Videos are useful. You know why? You don't understand, you can scroll back and then you listen to my explanation again. Now then you listen again, then you listen 2, 3, you listen 10 times, you still don't understand, then you message me, but no, don't wait until 10 times. You listen 1 time, 2 times, still don't understand, right? Maybe I didn't explain clearly. Then you PM me to find out what's going on so they can understand better. Okay, so this is the end of today's video. I will be making more videos for you to help you do all the worksheets. Please do them consistently. Don't wait until holiday almost ending then you do. Okay, when school opens, I will not be doing all this anymore. We have other topics to cover. Okay, thank you very much.